Separate control in square D contactors is a feature where the contactor coil can be energized independently from the main contacts. This means the contactor can be activated without the main contacts closing, or conversely, the main contacts can be closed without energizing the contactor coil. You would specify separate control when ordering a contactor for several reasons. Firstly, interlocking. Separate control enables the interlocking of contactors, preventing two or more contactors from being energized simultaneously. Secondly, sequence control. Separate control allows for sequencing contactors to control electrical equipment in a predetermined order. Thirdly, troubleshooting. Separate control enables the contactor coil to be energized separately from the main contacts, simplifying electrical issue troubleshooting. Fourthly, safety. Separate control improves safety by enabling contactor disengagement without cutting off power to the load. Contactors with separate control have additional terminals specifically for the control circuit. These terminals are usually labeled A-on and ATWO or coil plus and coil minus. Separate control offers greater flexibility in electrical control systems, improved safety and troubleshooting capabilities, and enhanced interlocking and sequencing possibilities. It's important to note that not all square D contactors have separate control. When ordering a contactor, specify the need for separate control if your application requires it. Consider an example of interlocking. Imagine two motors that should never run simultaneously. With separate control, you can wire the control circuits of the contactors so that when one contactor is energized, it prevents the other from being energized. This is achieved by using normally closed auxiliary contacts on one contactor to interrupt the control circuit of the other. For sequence control, think of a conveyor system where multiple sections need to start in a specific order. Separate control allows you to energize the contactors for each section sequentially, ensuring that the first section starts before the second, and so on. This can be done using timers or relays to control the energization of each contactor's coil. During troubleshooting, if a motor isn't running, separate control allows you to energize the contactor coil independently to verify if the coil is functioning correctly. If the coil energizes but the main contacts don't close, you know the problem lies within the contactor itself, possibly with the contacts or the mechanical linkage. Regarding safety, in an emergency, you might want to energize the motor quickly without cutting off power to other critical equipment. Separate control allows you to trip the contactor coil remotely, disconnecting the motor from the power supply without affecting other circuits. The presence of the A-on and ATWO or coil plus and coil minus terminals distinguishes contactors with separate control from those without. These terminals provide a dedicated connection point for the control circuit, allowing the coil to be energized independently of the main power circuit. Without separate control, the coil is typically energized directly from the main power circuit, meaning the contactor will activate whenever power is applied to the main terminals. When designing a control system, consider the benefits of separate control in terms of flexibility, safety, and troubleshooting. It may add some complexity to the wiring, but the advantages often outweigh the drawbacks, especially in critical applications. Also consider the voltage of the coil, the current that is needed to energize the coil, and the appropriate wire gauge for the control circuit. These considerations are crucial for ensuring proper operation and preventing potential hazards. Remember that different square D contactor models have different specifications, so always consult the manufacturer's documentation for detailed information. In summary, separate control in square D contactors provides a valuable feature for controlling electrical equipment in a flexible, safe, and reliable manner. It's essential to understand its benefits and applications to make informed decisions when designing and installing electrical control systems. When troubleshooting electrical problems with contactors, separate control offers a distinct advantage. For instance, if a motor fails to start, you can isolate the issue to the contactor coil by independently energizing it using the A-on and ATWO terminals. If the coil energizes but the main contacts do not close, this indicates a fault within the contactor, such as worn or damaged contacts, or a mechanical problem with the linkage. This targeted approach can save time and effort compared to troubleshooting a system where the coil and main contacts are directly linked. Separate control also enhances safety in scenarios where immediate disconnection of a load is required without disrupting the entire power supply. For example, in a manufacturing environment with multiple interconnected machines, a fault in one machine might necessitate its immediate shutdown to prevent further damage or injury. By utilizing separate control, the contactor controlling that machine can be de-energized remotely, isolating the faulty equipment without affecting the operation of other essential machines. When specifying separate control, it is important to consider the voltage and current requirements of the control circuit. The control voltage can differ from the main power voltage, allowing for greater flexibility in control system design. For instance, a 480 volts motor might be controlled by a 120 volts control circuit, providing a safer and more convenient means of operation. Additionally, the control circuit must be adequately protected against overcurrents using appropriate fuses or circuit breakers. Proper wire sizing is also crucial to prevent voltage drops and ensure reliable operation of the contactor coil. Consult relevant electrical codes and standards such as the National Electrical Code, specifically Article 430, for guidance on motor circuits, including contactor sizing and protection requirements. When designing interlocking systems, it is essential to carefully consider the logic and sequence of operation. Interlocking can be achieved through various methods, including hardwired circuits using auxiliary contacts or programmable logic controllers. Auxiliary contacts provide a simple and reliable means of interlocking, while programmable logic controllers offer greater flexibility in control over complex sequences. Regardless of the method employed, the interlocking system should be designed to prevent hazardous conditions and ensure safe operation of the equipment. Separate control also facilitates the implementation of sophisticated control strategies such as proportional integral derivative control, which are commonly used in industrial processes to maintain precise control over variables such as temperature, pressure, and flow rate. In these applications, the contactor acts as a final control element, switching power to a heating element, pump, or valve based on the output of the controller. Separate control allows for precise and responsive control of the process, ensuring optimal performance and efficiency. The use of separate control in square-D contactors offers several advantages, including enhanced safety, improved troubleshooting capabilities, greater flexibility in control system design, and the ability to implement sophisticated control strategies. When specifying contactors for a particular application, carefully consider the benefits of separate control and ensure that the selected contactor meets the specific requirements of the application. Additionally, it is crucial to adhere to all applicable electrical codes and standards to ensure safe and reliable operation of the equipment. The distinct advantages of separate control extend beyond the previously mentioned benefits, particularly when integrated with advanced control systems. Modern industrial automation often relies on sophisticated programmable logic controllers to manage complex sequences and processes. Separate control seamlessly integrates with these systems, allowing for precise and nuanced control over individual components and processes. For example, in a robotic assembly line, each robot arm might be controlled by a separate contactor with separate control. This allows the programmable logic controller to precisely coordinate the movements of each arm, ensuring smooth and efficient operation. If one arm encounters an obstacle, the programmable logic controller can immediately de-energize the corresponding contactor, stopping the arm and preventing potential damage. Furthermore, separate control enhances the ability to monitor and diagnose faults within the system. By monitoring the status of each contactor coil, the programmable logic controller can detect potential problems before they lead to equipment failure. For instance, if a contactor coil fails to energize when commanded, the programmable logic controller can trigger an alarm, alerting maintenance personnel to the issue. This proactive approach can minimize downtime and reduce the risk of costly repairs. The flexibility of separate control also allows for the implementation of energy-saving strategies. In applications where equipment is not required to operate continuously, separate control allows the programmable logic controller to selectively de-energize contactors, reducing energy consumption. For example, in a lighting system, separate control can be used to dim or turn off lights in unoccupied areas, saving energy and reducing operating costs. In addition to its technical advantages, separate control also simplifies compliance with safety regulations. Many industrial safety standards require the ability to isolate equipment from the power supply in the event of an emergency. Separate control provides a convenient and reliable means of achieving this, allowing operators to quickly de-energize equipment without having to manually disconnect power cables. When specifying D contactors with separate control, it is important to consider the specific requirements of the application, including the voltage and current ratings, the operating environment, and the desired level of control. D offers a wide range of contactors with separate control, each designed to meet the needs of different applications. By carefully selecting the appropriate contactor, you can ensure optimal performance, reliability, and safety. In summary, separate control in D contactors is a powerful tool for controlling electrical equipment in a wide range of applications. Its advantages include enhanced safety, improved troubleshooting capabilities, greater flexibility in control system design, and the ability to implement sophisticated control strategies. When specifying contactors, consider the benefits of separate control and choose the appropriate contactor for your specific needs. When installing and maintaining contactors with separate control, it's crucial to adhere to all applicable electrical codes and standards. These codes provide guidelines for proper wiring, grounding, and overcurrent protection, ensuring the safe and reliable operation of the equipment. Failure to comply with these codes can result in electrical hazards, equipment damage, and potential legal liabilities. Regular inspection and maintenance are also essential for ensuring the long-term reliability of contactors. This includes checking for loose connections, worn contacts, and other signs of wear and tear. Replacing worn or damaged components promptly can prevent unexpected failures and minimize downtime. Furthermore, proper training is crucial for personnel who work with contactors. They should be familiar with the operation of the equipment, the potential hazards, and the appropriate safety procedures. This training should include hands-on experience with the equipment, as well as classroom instruction on relevant electrical codes and standards. In addition to these practical considerations, it's important to stay informed about the latest advancements in contactor technology. Manufacturers are constantly developing new and improved contactors with enhanced features and capabilities. By staying abreast of these developments, you can make informed decisions about equipment selection and ensure that your control systems are up to date. Separate control is not just a feature, it's a philosophy of design that prioritizes safety, flexibility, and control. By embracing this philosophy, engineers and technicians can create electrical systems that are not only efficient and reliable, but also safe and user-friendly. Think of a large industrial facility with numerous motors, pumps, and other electrical equipment. Each piece of equipment is controlled by a separate contactor, and each contactor has separate control. This allows the facility operators to monitor and control each piece of equipment individually, maximizing efficiency and minimizing downtime. If a motor overheats, the corresponding contactor can be de-energized automatically, preventing further damage. If a pump fails, the operators can quickly isolate the faulty pump without affecting the operation of other equipment. In another scenario, consider a data center with thousands of servers. Each server is powered by a separate power supply, and each power supply is controlled by a separate contactor with separate control. This allows the data center operators to manage the power consumption of each server individually, optimizing energy efficiency and reducing operating costs. If a server is idle, its power supply can be turned off completely, saving energy and reducing the overall carbon footprint of the data center. The ability to remotely control and monitor individual contactors also facilitates predictive maintenance. By tracking the number of operations and the operating temperature of each contactor, operators can identify potential problems before they lead to equipment failure. This allows them to schedule maintenance proactively, minimizing downtime and reducing the risk of costly repairs. Separate control is not just about controlling individual pieces of equipment, it's about creating a smart, connected electrical system that can adapt to changing conditions and optimize performance. The integration of separate control with advanced control systems is transforming the way electrical equipment is managed in a wide range of industries. From manufacturing to transportation to healthcare, separate control is helping to create safer, more efficient, and more reliable electrical systems. To summarize, separate control is a fundamental concept in electrical engineering that has significant implications for the design, operation, and maintenance of electrical systems. By understanding the principles of separate control and its applications, engineers and technicians can create electrical systems that are optimized for performance, safety, and reliability. Separate control also offers significant advantages in scenarios involving renewable energy sources. Consider a solar power plant, where numerous solar panels are connected in series and parallel to generate electricity. Each string of solar panels can be connected to a separate contactor with separate control. This allows the plant operators to monitor the performance of each string individually and isolate any faulty strings without affecting the operation of the rest of the plant. If a string of solar panels is damaged by a storm, the corresponding contactor can be de-energized, preventing the faulty string from causing further damage to the system. The ability to remotely control and monitor individual contactors also facilitates the implementation of advanced grid management strategies. By selectively disconnecting or reconnecting strings of solar panels, the plant operators can respond to changes in grid demand and maintain stable power output. This flexibility is particularly important in areas with high penetration of renewable energy, where the intermittent nature of solar and wind power can pose challenges to grid stability. In addition to solar power plants, separate control is also beneficial in wind farms. Each wind turbine can be connected to a separate contactor with separate control. This allows the farm operators to monitor the performance of each turbine individually and isolate any faulty turbines without affecting the operation of the rest of the farm. If a wind turbine experiences a mechanical failure, the corresponding contactor can be de-energized, preventing the faulty turbine from causing further damage to the system. The ability to remotely control and monitor individual contactors also facilitates the implementation of advanced control strategies, such as curtailment. During periods of low demand or high wind, the farm operators can selectively curtail the output of certain turbines, preventing overgeneration and maintaining grid stability. Separate control is not just a feature for controlling individual components, it's a key enabler of smart grids that can integrate renewable energy sources efficiently and reliably. The integration of separate control with advanced grid management systems is helping to create a more sustainable and resilient energy future. As the world transitions towards cleaner energy sources, separate control will play an increasingly important role in ensuring the stability and reliability of the electrical grid. To reiterate, separate control in square D contactors is a vital feature that offers numerous benefits in a wide range of applications, from industrial automation to renewable energy. By understanding the principles of separate control and its applications, engineers and technicians can create electrical systems that are optimized for performance, safety, and sustainability. It's not merely about switching power, it's about intelligent control and efficient management of electrical resources.